Hello, everybody. I want to not introduce, but discuss some of the important features, some of the things that are not very easy to understand in this video. Okay, so this is about chapter 3, and we are talking about a collection class named Stack or interface named Stack. So a collection is basically a container. Okay, so what is a collection class? It's a container. It contains other objects. Okay, so it contains other objects. It organizes them so that you can access and retrieve them, access them, update them easily in a certain way, not just randomly, but in a certain way. So this is called a linear, right? A linear structure here. And this is nonlinear. So in this class, we will discuss linear structures. And abstraction, you can read this on your own and make sure you read because I'm trying to explain it with words. And if you don't understand it, let me know, but read it and you read it, okay? So collection abstraction. A class that uses a collection interacts with it through a particular interface. So here is the interface, and the interface will tell you what methods are there. And as a class, you use this collection. This is the collection class, okay? This is the interface. Remember, a class implements an interface. It must implement all the methods in the interface. So if you are a client class and you want to use that class, you know that it has all these methods. These are the methods, right? So that's what that is. Okay, you can read this. And now let's talk about stacks. So a stack is a classic collection. It's almost always the first one to discuss because it's very easy to understand. Okay, so the characteristics of a stack is that first in, last out, or last in, first out. If you look at this, this is the first one that is in, second, third, fourth, fifth. And so this is the last one in, right? When you want to get an element from this stack, it will be the first one to get out. So that's why we call it last in, first out. And it's always like that. So once this element is gone, then this one becomes the first one. It becomes the last one. So when you say pop, you will get this one. Okay, there is no way for you to access this unless you get rid of this. There is no way for you to put something in between these two. Whenever you put something onto the stack, it always goes to the top. It always goes to the top, okay? You cannot insert it in the middle. And you cannot get this one unless you pop all these. So that is what a stack is. It's last in, first out. And which means you have no access in the middle. You cannot update any element in the middle. You cannot get it. You cannot remove it. Okay. So here are the operations: push, and you can read the description. Push, pop, peek, it's empty size. So push is simply add an element, but in stack we call that push. It's you want to use this specific method, this verb to describe that method. That's classic. Okay, pop means you take it off, and peek means you only look at the top. You don't remove it. So the difference between pop and peek: pop is take it off, peek is to look at it and keep it there. It's empty means if the stack is empty, and size gives you the number of elements on the stack, okay? So you can review this, and we talked about this, but now we will talk about this generics, okay? Let's talk about generics. So generics, what does that mean? That means when you design a collection class, a collection, okay? A collection, remember, is a container, right? When you want to design a container class, you want it to hold objects. So what do you want it to hold? One time you might want it to hold books, another time you want it to hold potatoes, another time you may want it to hold treadmills. So you want it to hold different things at different times. So when you design this container class, you do not know exactly what it will hold, what the user will hold. And so you cannot dictate, you say, my container only hold this, or my container only hold this, right? So one solution is to let it hold object. You will say, my container will hold object. Well, if you declare that you hold object, guess what can go there? Anything can go there, right? Because anything is a child class of the object class. So if you say you hold object, then any class can go. And then when you retrieve an element from the stack, guess what? You do not know what it is. And it's a generic object and it's not useful. You have to know exactly what it is in order to use it, to call the methods of that specific object, right? So that's why if you think, okay, let's use this umbrella class as the type that container can hold, it doesn't work. So you can design a container class and say, my container only hold books. And then if you want a container to hold apples, what do you have to do? You have to design another container class and say, this container will only hold apples, and guess how many you have to design? Impossible to design them because there will be as many as you want, right? So that's endless. So that's not practical. So based on those problems, we decide a better solution is to define a class that's based on the generic type. So what is a generic type? This is a generic type, P. Okay, type. You can use any other words, character, but usually we use this. Okay, so you are saying public class box, and what does this box hold? You say T, a generic type. I don't know what you are going to hold, and who decides what it's going to hold. When you actually hold objects, when you actually create an object of box, and you will dictate what it will hold. So here, this is called a generic type. So when you use box, you replace that generic type with your own type, okay? Let's see, here we are using it, right? We are using this collection class and ways to create an object, an actual box, to create an actual box. And here you are saying, okay, I want a box that can only hold widget. So that's the syntax, box, widget. Box one is the reference variable. A new box, and you use that syntax to create it. Notice this parenthesis is after the name, okay? So this way, box one can only hold widget. If you want to put a book in the box, no way. You cannot put any other type except widget. Okay, and now you will say, what if I want to hold a gadget? Then declare another box, right? And now this box too will say it will hold only gadget. Okay. What if you want this box to hold books? Suppose you have a books class, a book class. Then you will say box, book. Okay, I'm going to go down and you will say box 3 equals to new box, book. So this is dictating parentheses. Remember, this is calling the constructor, so you need the parentheses. And this dictates what it will hold. Okay, that's how this works. So that's why we call this generic type. This is when you actually create the object, you replace it with the type you need. Okay. So that's generics, right? Now let's talk about this postfix expression. Okay, postfix expression is also actually called Polish expression. It means it has two operands and the operator is after the operand. Okay, so this is a postfix expression, two operands and the operator. This is equivalent to this infix expression 15 minus 8. Okay, so let's look at this expression. I will go through it gradually, step by step. So the first step is to write it all out. Okay, write all this out without the parentheses and just write it out. And then you will look at this and, oh, I'm sorry. But I'm looking at my own notes. Okay, the way to convert an infix is to write down all the numbers. That's the correct way. Write down all the numbers. Okay, write down all the numbers. And then you look at it. Okay, so here we need to do this one first, right? The 2 plus 5. And this should also be done first. So those two are really equivalent. They have the equal priority. When they are equal, what do? You go from left to right. So we will design this one first. 3 times 4, we will do this, and we add that, right? Add that there. Okay, 3 times 4. And then we need to do 2 plus 5. So we put plus there, okay? Plus here. And I have it here, plus here. And after those two are done, what do? Because of this parenthesis, you need to do the minus first. So remember, the minus is the subtraction of these two expressions. So this expression is subtracted from this expression. And this is the first expression. This is the second expression. So now you will do the subtraction of the two, and so your minus is here. Okay, so this whole thing is done for this one. So that is done. I'm going to erase that. And so this part is done, and now you will do this one, right? This one is this whole expression multiplied by this one, right? So you have this done already. And then you have 4, that's the 2 operands. So these are the 2 operands, and you place that multiplication after it. Okay. And after that is done, you have this whole thing done, and then you have 1 operand 2 there. So this whole thing is done, right? And then you have a 2. So those are the 2 operands. And what's the operator? Division. So that's how you do this. And I have explanations there, and you read it and practice several times and understand that you do have this on your test and quiz. Okay. So how do you evaluate this postfix expression then? Because postfix expression is operands first and then operator, right? So we can actually use a stack. Let's look at how this is evaluated. Okay, this is a postfix operation. So what does this mean? This means, okay, we don't do this, we don't do this, we do this multiplication. And this multiplication is always applied to the 2 previous operands. So we do this one first, and then we will have a result, right? And then you will continue, and then you have this plus. So the algorithm is really, how do we evaluate this? We push. If we see an operand, we push it onto the stack. Operand we push, operand we push. When we see an operator, what do? We remember that operator, and we pop We pop this one as the first operand, and we pop the second one, that one as the, no, I'm sorry, this one is the second operand. This one will be the first operand. Okay, so let's look at this vividly. We push 7 because it's an operand. We push 4 because it's an operand. We push -3 because it's an operand. And now we have an operator. So when we have an operator, what do? We don't push anymore. We pop this one and put it into the second operand. You have those variables, right? And then you pop 2 of them because binary operation needs 2 operands, right? So you pop this one and put it in the first operand. You have those 2 variables, and then you apply that operator, and then you have a result, which is -12, and you push that 12 onto the stack. And so now after this, after you encounter that operator, this is your stack. Okay, and so this is your current stack, and then you are here, right? And then you evaluated this one already. You encounter an operand, you push. You encounter an operand, you push, right? And then you encounter an operator, and now you pop. So you pop 5, that's the second, which is 5, and this one will be the first one. First will be 1, okay? And what's the operand, operator? Plus. So you add 1 and 5 together, that gives you 6, and you push that result onto the top of the stack. So just now you pop these 2, you still have this as your stack, and now you push your result up. Now this is your stack. And then you go on and you see, oh, this is an operator again. So when you see an operator, what do? You pop this one to be the first, the second one, and this one to be the first one. Okay, so you do -12 divided by 6, and that gives you -2. What do you do with the result? You push. So now that's your top. Okay. And then you continue with this string, and this is multiplication. What do? You pop. When you see a when you encounter an operator, you pop. Okay, so we pop -2. Now that's the second operand, and we pop 7. That's the first operand. Okay. So 7 multiplied by -2. That gives you 14, -14. What do you do with -14? You push. You push it onto the stack, and the authors in the book, they don't have this step, so I added this, okay? So you push it onto the stack. -14 is on the stack, the top one, and the only one in this case. And then you continue to evaluate, and now it says no more. We are done, right? Has not. It has next? No. So what do? Now you are done. You come back to your stack and you pop it. That is your result. That's how this postfix expression is evaluated. And the benefits of this, you can easily see. You don't have to pay attention to parentheses. You just, okay, if it's an operator, if it's an operand, push, operand, push, operand, push, operator, okay, pop the top one as the second operand, and then pop the next one as the first operand. Evaluate, calculate, and push the result back. And then operand, push, operator, you pop. So that is the algorithm. And this is the main method that's using that, right? We use this one, this evaluate method to evaluate the whole expression. And so you will read this carefully. I don't need to explain it. Okay. So let's look at this. Here, we are declaring a stack, right? In this postfix evaluator class, we declare this stack, and its type is integer. That means you can only push integers onto this stack, okay? And these are just final final constants, okay? So this stack can only hold integers, and here you're instantiating the stack, okay? And I have detailed explanations here. I think you can read it, and if you don't understand it, let me know. You can always reach me via office hours. You know that, right? The office hours is posted there. I'll post it there on the Canvas webpage. So since I explained these already, I will let you read them, okay? And that's basically it, right? Okay, so let me explain this syntax. Stack push, okay, new integer. Why do we do new integer? I think I explained that somewhere. Because a collection, a stack can only hold objects. It cannot hold primitive data types. And this is where the wrapper classes come in. You remember we discussed wrapper classes in class 2. Wrapper classes correspond to the primitive data types. There were 8 of them, right? Integer, character, Boolean, long, double, float, Boolean, and what else? Okay, there are short and byte, yeah. Okay, so those are the 8 primitive data types. And then you have the corresponding wrapper classes for each of them. And integer is the corresponding wrapper class for int. So result is an int. Notice these are all int, okay? Int. So you need to make it into an integer and then push it onto the stack. New, make it an integer and push, okay? And here we are, this is token, right? Token, what is token? Token is a string. Token is a string. So you need to make that string pass int, you need to make that string into an int using this static method of integer. This pass int is a static method of integer. You need to use that to convert this string into a number, and then using that number as an argument to make a new integer object, and then push that object onto the stack. Okay, that's that. Okay, so I will let you read that. And I don't need to explain this. And Java doc, you watch the video I have. It shows you how to generate this, how to install things, okay? And because this doesn't really need explanation. Exceptions, so this is a design issue. When do you need to throw an exception with a stack? Think about it. If you have a stack, I'm supposed to be able to push elements forever. No, until it reaches the sky, right? There should be no limit. So push should never throw an exception because it should be limitless, endless. Well, that's okay, but when you pop, you might have no object to pop. Your stack might be empty. Your system cannot ensure your stack is not empty. It can ensure you can forever push, but it cannot ensure the stack is not empty. So when you pop, and the stack is empty, when you do another pop, you should say, this is an exception. I do not have any object for you to pop anymore. So in that case, you should throw an exception. Okay, that's the pop. And then for peek, it's the same thing. You want to see what's on the top? There is no top. It's empty. So for peek, you should also throw an exception. But for push, no. It should be always available for you to put something there. Okay. So this is the stack interface. Remember, interface, you have the keyword interface, and you end it with a semicolon and no body, right? That's the header of the method, and then you end it with a semicolon. So these are the classic methods here, and you always have the toString, and we discussed that in class 2, you always have a toString method because the object's toString returns only the object ID. So you want to have a meaningful toString method. And what does the toString method do? It returns a concatenated string of all the instance variables. Okay, so implementing a stack, I think I'm going to do a video with this by itself, and I'm going to implement and use the stacks. Okay, everybody, I'm going to stop here.